Hello friends, welcome to this session on turtle art. In this session, we will be discussing how to draw various objects in Python. In this process, we will be learning various important constructs of a programming language. Let us start this session. Let's jump to Spider to start its implementation. First, in order to work on turtle art, we have to import a module called as turtle in the beginning of our code. This module contains a very important class called as turtle, which carry all important function which is used to draw various objects on the screen. Let us first create an object of turtle class. In order to use turtle class, we have to create its object. The syntax to create object is object name. This is user defined object name. Then module name dot class name. So let us create an object named as tortoise by using this syntax. So after this, we have to give the name of module, which is turtle. So let's specify this. Then we have to specify the class name. The class is turtle. So it is important to note that the class name is turtle, but it is written with T in capital letter, while module name is also turtle, where T is written in lowercase. And also class name involves brackets. So here we are creating an object with name tortoise, and this object is created from a turtle class which is present in turtle module. Now we have a tortoise object which will help us to draw any object on the screen. Let us run this code to check its output. So here we have executed this code, and you can see that once you run this code, you will get another window which carry turtle graphics, and in this turtle graphics we have something like this. This is our tortoise object which will be used to plot any object on the screen, and by default its position is 0 0 on the screen. Now let us check its position. We have a function called as position. This position function is actually help us to provide the exact position in terms of x and y coordinates of our turtle object on the screen. So you know that all these functions are defined in the class turtle, but in order to invoke these functions we have to require object instance. So here object is tortoise, and by using this object I am invoking the function position which is defined in class turtle. Let us run this code to see its output. So you can see that by default its position is 0 0. Now let us move this object on the screen, and it's important to note that when this object move on the screen, it will leave a mark on the screen. It means that when it moves on the screen, it will leave ink on that particular path. Let us move this turtle object forward by say length 100. So in order to move this turtle object, we have to use object name which is tortoise, then the inbuilt function is forward. In this function we can specify the length or the distance which we wish to move. In this case we are moving forward 100. So let us rerun the code. So I am resetting my kernel again. Let us execute these statements, and here you can see that we have a line. Now turtle move from this position to this position, and during this movement it has drawn a line of length 100. Can you guess what is the position of my turtle object at this point? Yes, in order to check this position we can invoke this function again. So let us check its position at this point, and I hope you know the answer. Let us first execute it. So the answer is 100 0. Because this is the original position with 0 0, we have moved 100. So there is no change in the y-axis, while x-axis has moved from 0 to 100. So the x-axis is 100 while y-axis is still 0. Now can we extend this process to draw a square on the screen? Okay, so in order to draw a square, we have to first of all change the orientation of my turtle object, which is going in this horizontal direction to vertical direction in this way. So here you can see that I wish to move my turtle from this straight line to upper vertical axis. And in order to move in this direction, I have to follow this path. So this path is anti-clockwise. So when we move anti-clockwise, we called this as left. So we have to move our turtle towards left side. So at present, this is the default orientation and we move towards this side. And this movement is left. And can you tell me what is the angle of left? Of course, the outer angle is 90 degree. So we have to change the orientation of our turtle object left 90. So let's use this. So this is my object. We have a function called as left where we can specify our angle, and in this case our angle is 90. So let's restart this kernel again and run this code to check its output. And you can see the output is this. So it's important to note that turtle object has changed its orientation from horizontal line to vertical top side. But still no line has been drawn because we just use left angle, left 90. So it changed its orientation. Now at this point we can draw the line. And in order to draw the line, I can move forward 100. So let's copy this code, forward 100, and paste it here. Let's rerun this code. So this is the point. So we have moved from this point to this point. Now this is the current position of my turtle object. Can you tell me what is the value of x and y axis at this point? I mean, we started from this with 0, 0. We moved 100 with x axis 100, y 0. Now we perform this operation. So I hope you know the answer. The x axis will be 100 while y axis will also be 100. So let's run this code to check its position at this point. Executing this statement on this, and you can see that now x axis is 100 while y axis is also 100, and this is our current position. Since we have to draw the square, can you tell me what should be the next operation? So at present our turtle is moving in this direction while we have to follow this path. So first of all, we again have to change its angle, and this is the direction in which we wish to move. So this is still this path which is anti-clockwise. The side will be left and the angle will be 90. So the same code left 90 will be used here to change its orientation. So I am executing left 90 again. Let us execute these statements. Let's check it output. Yes, so it has changed its orientation by using left 90. Now I hope you know how to proceed further, and you can pause the video at this point and you can complete the code so that we should have a full square on our screen. While if you wish, you can play this video and you can see the remaining portion of the code. So we have at this point and we wish to move forward 100. So let's use forward 100 again. Let us check output at this point. So we reached at this position. So now this is the direction in which we wish to move. This is again anti-clockwise. So left 90 and then forward 100. So let's do these operations in one go. Left 90, forward 100. Let us execute this portion of the code. So if you check, the output is like this. In the end, we wish to have our turtle again at the same orientation from where we started. So we can perform another left 90 so that turtle should have the same or original positions from where we started. So let's perform left 90 again so that turtle should have its same original position. So you can see here the turtle is at same original position. So here we are running this code in steps. So let's close this console to see the output in one go. So let us execute this code, and this is our final square. Good. So you can see that our turtle is at the same point from where we have started. So this is the final code for drawing square on the screen. Please look closely to this code. And now the next question is, can we optimize this code? We will be optimizing this code in our next session. So thanks for watching this video. The code discussed in this video session is given in the description of this video, so you can directly copy paste it and apply it. Thanks for watching this video. See you in next session. Bye bye.